again. Now we're just going to move on now into centre of gravities of shapes using basic formulas. So we're going to use the same idea as we did with the point system. So here we have a square with a circle and a triangle removed. So I'm looking now at the question that's on the handout I gave you. It's this one here I'm looking at, number 16. So I've just taken all the information from this question. It says you've got a square with vertices A, B, C, D, and it has a triangle and a circular portion removed. And then it gives us the coordinates of all the necessary parts. So you're going to use the law of moments to help you solve this. So it's basically the same as the point system. The only thing is we don't have any force. We don't know the weight of the triangle or the square or the circle. So we're going to use the link that we're going to use force per unit area to allow us into a force. So that means the area of the square, if the area of the square is 10, then the force of that square is 10W. So the force per unit area I'm going to call weight W. Okay, so basically I'm setting up a table as before. So I've got three shapes here. I've got a square, and ultimately the two things that are taken out of it are the triangle. So we're going to minus a triangle and we're going to minus a circle. Okay, so this is what we're concerned with. Now, to do the law of moments, I need forces, I need positions of centre of gravity, I need the moments about the x-axis, and I need the moments about the y-axis. The same idea as we did with the point system. Okay. Now, the square. The force of the square is the area of the square per unit, the force per unit area. So the area of the square is 12 by 12. 12s are 144. So the force for that square is 144 by W. The triangle is here. It has an area of half the base by the perpendicular height. So the base of that triangle is 6 units. So half the base will be 3. 3 times the perpendicular height is 12. 3 12s is 36. The circle has an area of 3 pi r squared. The radius of this circle is 3, so that means the radius is pi 3 squared, so that's 9 pi w. Now the centre of gravity, let's have a look at them. The centre of gravity of a square is slap bang in the middle of it, so that's easy enough. That's at position 6, because this square, 6 along 6 up, is right in the middle. Now, the centre of gravity of a triangle. This is a formula maybe that you haven't yet met yet. I'm not sure if you have in geometry. But the area of a triangle, the centre of gravity of a triangle is given as 1/3 the sum of the x coordinates and 1/3 the sum of the y coordinates. So that's your centre of gravity of a triangle. So this particular triangle here, the x coordinates are 6, 12 and 12. So that's going to give me 30. And 1/3 of 30, of course, is 10. And then I'm going to look at the sum of the y coordinates, 0, 0 and 12. So that gives me a sum of 12. And 1/3 of 12 is 4. So the centre of gravity of that triangle is at position 10, 4. The circle, of course, the position of centre of gravity of the circle is right in the middle of it, which is given as 3, 9. Okay, so that's my information. Then I continue as I was doing with the point systems. And the moments about the x-axis will be 144 by 6. And when I work that out, that becomes 864W. The moments for the triangle is 36 by 4, and that is 144W. Now, because the triangle was removed, these numbers here, which I didn't put in, they should be minus, because the triangle and the circle are being removed, so this is a minus. The moment for the circle about the x-axis, I'm going to multiply that 9 pi by 9, which will give me 81 pi. W, and again it's removed, so it's minus it. I'm going to do the same then for the y-axis. So this will be 86 for W. This one will be minus 36 by 10, which is minus 360 W. And this last one here will be minus 27 pi W. Okay, so now I have all my information. I'm going to get the sum of the resultant. I don't know the position of central gravity, and I'm going to get the sum of the moments. So remember, the sum of the moments equals the moment of the sum. So I'm going to do the x-axis first. All right, now, the sum of the moments. First of all, the sum of that resultant, I'm going to add 144W, take 36W from it, and take 9 pi. Pi, remember, is 22/7 or 3.14. So when I work that out, that becomes 79.73W. I don't know where the central gravity is. I'll call it xy. When I work these figures out, when I take 864W minus 144W minus 81 times pi, again, which is 22/7, I get 465.5W. And when I do this last column and put in for pi, I get 419.17W. Okay, so let's take my x-axis. The sum of the moments about the x-axis is 465.5W is equal to the moment of the resultant, or the moment of the sum about the x-axis, which will be 79.73W, that's my resultant, by y, when it's moments about the x-axis. And when I work that out, I'll get y is equal to 5.84, and do the same for the y-axis, exactly the same again. So I take the sum of the moments about the y-axis, which is 419.17W. I'll put that equal to the moment of the resultant about the y-axis, which is 79.73W times x. The x will then become 5.26. So my centre of gravity is at 5.26, 5.84. Let's try another one. So I'm going on to the next sheet, the next page, which is number 17, and we're going to have a look at this one here. We've got a triangle with vertices A, B, C, and it has another triangle removed, and the vertices A, D, C, that's the bit that's removed, so that's taken out. Now the coordinates of the points are given, so I've listed them. Look, put those into that diagram. I've got to find the coordinates of the centre of gravity of the remaining lamina. Okay, so I've got everything in position. I'm going to get the forces. Now I've got two triangles, so I'll say triangle, the big one, and triangle small. So I'll call it triangle B and triangle S. S is the one I'm removing. The information I want, of course, are the forces, the centre of gravity, the moments about the x-axis, and the moments about the y-axis. So again, I'm going to use the law of moments. Okay, so my large triangle, I'm going to use the force per unit area again idea. Force per unit area is W. So the area of the large triangle is half the base by the perpendicular height, so half 12 by 15. That's going to give me 6 by 15, 90. So that's going to be 90W. The area of the small triangle is half the base by the perpendicular height as well. Now, small triangle doesn't have a typical perpendicular height. So for this one, I'm going to have to use a formula for area of a triangle. Now, it's in your log tables. You'll find it as a half times x1, y2 minus x2, y1. Now, in this particular case, the triangle that we're after is 0, 0, 6, 6, and 0, 15. 0, 0, 6, 6, and 0, 15. So those are three vertices of that small triangle. To use this formula, one of the vertices has to be 0, 0, which it is. So therefore, I can just put these in as x1, y1, x2, y2, and find the area of that triangle. So this becomes a half, 6 times 15, minus 6 times 0. So that will just give me a half of 90. And a half of 90, of course, is 45. So the area of this small triangle is 45W. So check out, make sure you know where you got that formula from. It should be in your log tables. It's a geometry formula. When you're given vertices of a triangle, you can find its area. And if one of them is 0, 0, it makes it nice and handy. Now, the centre of gravity of each of those positions. So this one here, remember this big triangle, the centre of gravity is 1/3 the sum of the x's and 1/3 the sum of the y's. So for that big triangle, call it the triangle, 1/3 the sum of the x's will be 0 plus 12 plus 0, and the y coordinates will be 0 plus 0 plus 15. So this is your centre of gravity of the big triangle, which is 4, 5. You do the same for the small triangle. 1/3 the sum of the x coordinates, 0 plus 6 plus 0, and the sum of the y coordinates, 0 plus 6 plus 15, that's 21. So 1/3 of 6 is 2, 1/3 of 21 is 7, so the centre of gravity is 2, 7. Okay, let's do the moments about the x-axis. 90 by 5 will give me 450W. 90 by 4 will give me 360W. Now this small triangle is being removed, so it's minus that small triangle. So this will be minus 45 by 7 is 315W, and 45 by 2 is minus 90W. Okay, so I have all my information. I'm going to use the law of moments. So the actual resultant will be 45W. I don't know where the centre of gravity is. I'll call that XY. I'm going to subtract these two figures here to give me 135W, and I'll subtract those two to give me 270W. Then I'm going to use the law of moments, which says the sum of the moments equals the moment of the sum, or the moment of the resultant. Moment of the sum. So let's do the x-axis first. The sum of the moments about the x-axis is 135W, is equal to the moment of the sum about the x-axis will be 45W by y, which means that y is equal to 3. And now do the y-axis. The sum of the moments about the y-axis is 270W, is equal to the moment of the sum about the y-axis, which is 45Wx. So this gives me x is equal to 6. So my centre of gravity is 6, 3.